Hello, today we're going to learn how to model and calculate supply and demand using real-world scenarios. These scenarios will be taken from a fast food restaurant called Whataburger. It's a drive-through restaurant that's popular in the Southwest United States. It's very popular with my students, so they chose at the beginning of the semester a menu item called the honey barbecue chicken strip sandwich that we will use as our product for this. And what we're going to do in this tutorial is learn specifically how to model and calculate supply and demand using scenarios taken from real life. These are actual things that could happen at Whataburger and have happened at many fast food restaurants and other dining establishments. This is the sort of thing that you will encounter in the real world if you enter food service. So there should be some applicability here more broadly. For this tutorial, you will need possibly a very simple calculator. It only needs to add, subtract, multiply, and divide. You might not even need that, but it's good to have on hand. I would recommend a variety of colored pencils or pens or markers. I would also recommend maybe some multicolored highlighters just to have on hand, and certainly a good pencil because you want to be able to erase mistakes. Finally, with supply and demand analysis, you will need, ladies and gentlemen, some kind of straight edge. It doesn't have to be anything fancy. A ruler will suffice. I prefer to use a plastic straight edge that is see-through, kind of like that, so I can see what it is that I'm doing. So let's clear the deck and get started. We're going to look at 7 scenarios that could happen, and I will walk you through each one. So let me just clear the page here, and we'll move on to the tutorial. Okay, this is the worksheet that you have 7 copies of. Each worksheet is exactly the same, and we will place one of the scenarios on each worksheet. So you see I've got 7 of these, and they all depict the same supply and demand curves, and they have the same numbers. We're just going to change the scenarios for each one. That way we don't clutter up our single graph with trying to model 7 individual scenarios. Okay. Let's start. There are some things we should notice right away when we look at this graph. When you see a supply and demand curve, your eye should immediately begin to locate that point where the 2 lines cross. That will be important. So what I'd like to do before we do anything else is take some kind of colored pencil that will stand out and highlight that point. All right, that is our market equilibrium. Then we need to make sure that our graph is labeled correctly. Now, these graphs are intentionally left unlabeled for student testing. So we're going to label these points on this graph before we start our analysis. So test yourself. This vertical axis here should be labeled P for price, and the horizontal axis is Q for quantity. The downward sloping line with inverse proportionality is the demand curve, and the upward sloping line with a positive correlation is the supply curve. As we said, this center point here is the market equilibrium. Now, you don't have to use the colors that I'm using, but I want it to stand out. So we're going to label this E1. So this is the first equilibrium that we're going to find. Today we won't be finding other equilibriums, but they do come up in future tutorials. So this subscript will indicate the equilibrium that we're working with. So all of our points that relate to this scenario will be points 1. Okay. All right, so once we've determined our market equilibrium point, we need to find out what X and Y values correlate to the market equilibrium. So we'll start with the Y value. What you do is take your center point and make a dot, dot, dot out to the Y axis. And I realize viewers cannot see the numbers printed here. This says $9. So the market equilibrium price, we'll call this P sub E1, is $9. And I'll just write that out in big numbers so you can see that it's $9. Okay, this is the price of the honey barbecue chicken strip sandwich. Now, what about the market equilibrium quantity? Well, let's take our ruler or straight edge and mark down from the intersection point of the supply and demand curves to where it hits the x-axis or the quantity axis, and we see that the quantity equilibrium 1 is equal to, I'll write this here below it, 2.5 million sandwiches, which we'll just call 2.5. Now, this is important. I'm not sure I emphasized this enough in class. This quantity equilibrium, where the supply and demand curves meet, at this point and this point only, this quantity equilibrium, I'll write it over here. When you see a quantity equilibrium or a price equilibrium, okay, this is the price demanded and the price supplied, and the quantity demanded and the quantity supplied. So this is the same, okay, for supply and demand. That's why it's called the equilibrium. It's where the market is at equilibrium. So supply and demand have the same point that they share. And really, divergence from this equilibrium is what makes economics interesting. And that's what we're going to model in these scenarios. So we've got a few things to set up yet. We need to determine these 3 points right here, and then we can get started with scenario analysis. All right. What is the initial equilibrium price? Well, we found that. That's $9. So we'll write in here $9. What is the initial equilibrium quantity? All right. Well, that's 2.5 million sandwiches. And I do want you to write out what it is that you're indicating. So 2.5 million honey barbecue chicken strip sandwiches. What is the initial break-even price? This is intentionally confusing because of this word right here. I'm asking you to locate a point on the price axis, but it will actually refer to a cost, okay, parentheses, this is a cost to the producer, in this case Whataburger. What is the break-even price? In other words, at what price, below what price can they not sell any sandwiches without losing money? Well, I'm simplifying things a bit with this graph, but it's relevant and interesting. So actually this point right here, it's indicated by $6. In other words, the y-intercept of the supply curve is the break-even point. So that's where the quantity supplied, if we move down, we find that the quantity supplied right there is 0 units. So that break-even price or break-even cost, we'll call this the, just to make it simple and clear, we'll call this the break-even point. All right. This becomes relevant in one of the examples, and it's $6. Okay, so that's $6. And we'll just indicate that right here, $6 per sandwich. So make sure you're filling this out. You don't have to fill these things out on every single page, but do fill it out on one of them. All right, let's see what we're asked to do here. It says, Whataburger real-world supply and demand scenarios. Instructions. Imagine how each scenario would affect an actual Whataburger restaurant. Draw each scenario on the graph above and fill in all applicable fields. Note, you may use additional scenario sheets for convenience. Okay, what I'm asking is that for students when they turn this in, that you transfer all of your values to one of these tables and then turn that in. I don't need you to turn in all 7 pages. But let's start with scenario 1, and I'll read it because I don't think this camera is picking up such small text. The first scenario says, Whataburger installs a robot to make chicken sandwiches, which reduces production costs by $1 per sandwich. All right. We have to decode that into economics language. So it says here, Whataburger installs a robot to make chicken sandwiches. So they're replacing an employee or employees with a robot, and we're to assume that this technological improvement causes production costs to go down. Well, by how much? By $1 per sandwich. That's why I modeled the break-even point here on the graph. So if costs go down by $1, what we're going to do is reduce our break-even cost by $1. These are incremented in 50-cent increments, so we're going to go down a full dollar, and this is going to be our new break-even price. So we'll call this, I guess, break-even 1, right? And that's equal to $5. And I'm just reading that right off of the y-axis or price axis. Now, what do I do? What do I do? Because down here, I'm asked to show the new quantity supplied, the new quantity demanded, any change in price, that's menu price. As we look at this, be careful. Okay, I'm saying any change in menu price. Is there a surplus or is there a shortage? Another thing that we have to remember in economic analysis is that everything else stays the same except for the thing I'm changing. The Latin phrase is ceteris paribus. Assuming all else stays the same, just change this thing. So we're going to change one thing and see the effect that it has on the graph. That's what we're going to model. So now I'm going to draw a new curve. Well, am I drawing a new supply curve or a new demand curve? Am I going to draw a new demand curve? Did demand change? No. No, it said that production costs went down. That's all we know about this particular scenario. So we'll take a different color and we're going to draw production costs are related to supply, so it looks like supply changed. Well, remember that the law of supply is that when the cost or price goes up, the quantity supplied goes up, and when the price or cost goes down, the quantity supplied goes down. But here's this is where it's intentionally confusing. This is a menu price right here. So the thing is, when costs go down, quantity supplied goes up. So we'll model that here. I'll use a darker color, and we will model that right here by drawing in a new supply curve. Now, the only key thing here is that when you draw it in, make sure it's parallel to the original, but just shift it down to where the y-intercept is now at the new break-even cost. We're going to draw that in right here. This is my new supply curve. So we'll call this S1 for the new supply curve for scenario 1. Now we have to do some analysis. We have to do some analysis because we say that the price didn't change. So what does that mean? How do we determine the new quantity supplied? Well, we have to extend out our price line. What you do in these situations where the price didn't change is you take your original price of $9 and extend out the price to see where it impacts the new curve that you drew. And we're going to place our new impact point right there. And then, in order to find out the corresponding quantity, what you do is drop a vertical dotted line from this new price, or from this new supply curve down to the quantity axis and see where that is. All right, that's right here. And that point on the quantity axis, this is quantity supplied for scenario 1. That point is equal to 3.25 million sandwiches. Okay, so for scenario 1, we can fill in some information. The new quantity supplied is 3.25 million sandwiches. Quantity demanded, ladies and gentlemen, is still 2.5 million. It did not change, and that's the problem. So the quantity demanded is still 2.5 million. Did price change? Did price change? No, price is still $9. You can choose to leave that in, but since I'm asking for change in price, then you can just say there was no change in price, put a line through it, or say not applicable, not applicable, or you could even put 0 or 0 with a line through it, something to indicate to me that you know that price did not change. Okay, well, we have to ask ourselves, does this constitute a surplus or a shortage? Well, we said that we increased supply. Okay, we increased supply. Demand did not increase. So in other words, we made more sandwiches, but no one wants the extra sandwiches. So we have leftover sandwiches. We made too many sandwiches because sandwiches got cheaper to make. We made more of them, and now we have too many sandwiches. So we have a surplus. That's the definition of a surplus. And how much of a surplus we have is calculated by subtracting the quantity demanded from the quantity supplied. So if these were bigger numbers or we didn't know what to do, we would say the quantity supplied 3.25, subtract out the quantity demanded of 2.5. So we'll say that the surplus is 0.75 million sandwiches. We have a surplus now of 750,000 sandwiches, okay, or 0.75 million. So there is no shortage. This is a surplus situation, so that's empty. And that is the end of scenario 1. We did it. We computed the new quantity supplied. We drew the new supply curve. We modeled the new price. We modeled that the price stayed the same. We modeled the new quantity supplied number and computed the surplus amount of 750,000 sandwiches of quantity supplied. So the question is surplus a good thing? Well, when you're talking about the United States budget, maybe a surplus is a good thing. But when we're talking about Whataburger, we don't want to have surplus sandwiches on hand. We would ideally like to make just enough sandwiches to sell all of them and have no leftovers. So in this case, a surplus is not such a good thing. So is it a good idea to install the robot? Well, maybe. We would have to see where the new supply and demand find equilibrium, but we're not going to do that in this lesson. So that is scenario 1. Put that aside, and we're now back to a blank sheet of paper for scenario 2. So I'll very quickly relabel a couple of points. This was my initial equilibrium point, and my initial price was 9. So this is price equilibrium, and my initial quantity was 2.5 million sandwiches. So I'll just draw that down and make this the quantity equilibrium. and we'll call that 9, and this is 2.5. Just get back to where we were. Now let's proceed with scenario number 2. Let's read what it's asking us. It says here, the price of Whataburger's patty melt sandwich, a substitute, increases, causing demand for the honey barbecue chicken strip sandwich to increase by 1.75 million sandwiches. Okay, so the price of a substitute increased. When the price of a substitute increases, the demand for the product that you're using, in this case the honey barbecue chicken strip sandwich, goes up because the substitute got more expensive. Like if you're going up to the drive-through window, okay, and you've got 2 menu options, the patty melt and the honey barbecue chicken strip sandwich, and the price of the patty melt has gone up dramatically. It's doubled in price. Then the people who would have chosen the patty melt sandwich are now going to choose the honey barbecue chicken strip sandwich because relative to the patty melt sandwich, it's now the cheaper item on the menu. Okay? If they're indifferent, if their only determinant is price. Oh, since we got a new curve, we better label our axes: price, quantity, supply, and demand. All right. Okay, so it says here, there's a bit of a red herring here. The price of Whataburger's patty melt sandwich, a substitute, increases, causing demand for the honey barbecue chicken strip sandwich to increase by 1.75 million sandwiches. So let me ask you a question. Did the price of the honey barbecue chicken strip sandwich go up, or did the price of the substitute go up? Your mind should be working to tell you that the price of the substitute went up, not the price of the honey barbecue chicken strip sandwich. So whatever happens in this example, we are not, ladies and gentlemen, going to change this price. All we are given is that the demand for the honey barbecue chicken strip sandwich increased by 1.75 million sandwiches. So here's how you actually model this. If you don't really know quite what to do, start here. Go to the quantity that you know, 2.5 million, and increase it by 1.75 million. So if you didn't know what that was equal to, you would say 2.5 plus 1.75 equals 4.25 million. So locate 4.25 million on your horizontal or quantity axis, and then what you're going to do is extend up this point all the way through your graph to see where it hits the lines. Okay, so just put it all the way up through. Now the question I asked before is relevant. Did the price of this honey barbecue chicken strip sandwich change? No. The price stayed the same, so we're going to extend out our price line to hit this point. And this point right here, where the price meets the quantity, that's the new point through which we are going to draw either a supply curve or a demand curve. This is where your thinking has to come into play, the economic thinking. Let's go back to the problem. Oh boy. The price of Whataburger's patty melt sandwich increases, causing, keyword, demand for the honey barbecue chicken strip sandwich to increase. So demand increased. So we know that we're going to shift the demand curve in this example. That's how we know that. So now you're going to draw a new demand curve, not a supply curve. So we'll use a purple. That's not showing up very well in the camera. Let me use orange to draw the new demand line. So we're going to make a demand line pass through this new point, and we're going to make that demand line parallel to the original demand line. So I'll just draw it here. There's my new demand line. So this is demand for scenario 2, demand 2. Price did not change. So the sandwich still costs $9. But now people are demanding more of it. They're demanding 4.25 million. So quantity demanded for scenario 2 is 4.25 million. All right, so what is going on here? We can now try to figure that out when we go down to our sheet and see what is the quantity supplied. Did it change? No. The quantity supplied is still equal to 2.5 million. So you can put a mark through quantity supplied. Oops, wrong line. Put a mark through quantity supplied. Quantity supplied did not change. That's actually the problem. You know, the quantity supply did not change. Did quantity demand change? Yes. Yes, it did. How much did quantity demand change? Well, it changed. The difference is 4.25 million minus 2.5 million. That's equal to 1.75 million sandwiches. So you could say quantity demanded increased by 1.75 million. Okay? Did the price change? No, the price did not change. So now, do we have a surplus or a shortage? This is the real key. This is where it gets kind of conceptually difficult. Well, let's look at the demand, economic model. So we have demand that went up. Demand shifted to the right, so it went up. Quantity demanded increased by 1.75 million sandwiches, but quantity supplied is still 2.5 million. So in other words, if you go up to the drive-through window and order a honey barbecue chicken strip sandwich, they're going to sell 2.5 million, and then after that, people are going to still be asking for it. Hey, can I please have a honey barbecue chicken strip sandwich? And the person working the drive-through window will go to the person making the sandwiches and say, can I have a honey barbecue chicken strip sandwich? And the person producing the sandwiches will say, I don't have any more. We're out. And so they are short. That's what you would say in the restaurant business. We're short that menu item. So we have a shortage here. Demand increased, but supply did not increase. So we do not have a surplus. Instead, we have a shortage. Okay, we have a shortage. And that shortage is equal to the increase in demand. So the shortage is equal to 1.75 million sandwiches. That's the shortage. Okay, so there's no surplus here. And that's it. You've completed scenario number 2. So check that box. And we'll move on to scenario number 3. All right, very quickly, I will relabel my graph. Price, quantity, supply, demand. And then this point right here is my market equilibrium. And this point right here is my price equilibrium at $9. So $9 is my price equilibrium. Down here, my quantity equilibrium is at 2.5 million sandwiches. So that's my quantity equilibrium, Q sub E. Remember, that's the quantity demanded and the quantity supplied. Q sub E, quantity equilibrium, is equal to 2.5 million sandwiches. Now let's see what scenario 3 asks us to do. Okay, it says here in scenario 3, the price of chicken increases, causing output to drop by 750,000 sandwiches. Oh boy. So what's going on here? See, again, I'm using this word price. But am I talking about the price of the menu item honey barbecue chicken strip sandwich? No. I'm talking about the price of the chicken that you use to make the sandwich. So in this case, when I say price, what I'm really saying is cost. So the cost of making the sandwich went up. Well, when costs go up, the supplier makes fewer sandwiches. So Whataburger had to pay more for the chicken that they put on the honey barbecue chicken strip sandwich. So they reduced output, or they made 750,000 fewer sandwiches. So they reduced their production by 750,000 sandwiches. Are you thinking that this is a supply or demand scenario? Well, if you're thinking supply, you are, ladies and gentlemen, on the right track. So how do we model that change in supply? Well, we start with 2.5 million and we reduce supply by the quantity supplied by 750,000 sandwiches. Since this is denoted in millions of sandwiches, we'll take 2.5 million minus 0.75 million to find a new quantity supplied of 1.75 million. Locate that point on your graph. There it is. So this is the quantity supplied for scenario 3, and that is 1.75 million sandwiches. And what you're going to do is take your straight edge and extend that new quantity supplied all the way up through the graph until you see it cross both the supply and the demand. Well, now what do I do? Well, in the previous problems, because the price on the menu of the sandwich did not change, we would extend out the price line, but in this case, the quantity actually decreased, so we don't need to actually draw in a new price line. It's there. So we just find that point where price and quantity meet and make a mark. So we're going to draw a new line. Are we going to draw a new supply line? Or are we going to draw a new demand line? Well, we said that quantity supplied decreased. So there was a decrease in supply. So the supply curve shifts to the left. That means we're drawing a new supply line. So I'll use, for this one, just to keep varying the colors, I'll use this kind of blue-green color. And passing through that point, I'll draw a new supply line. Okay, right here. This is my new supply. So this is supply for scenario 3. I didn't ask you for this, but it's easy to find. If I said, what is the new break-even cost? You could just read it right off the curve at $7. At $7. So it looks like the cost of making the sandwich went up by $1. So quantity supplied went down by $1, or by 1.75. Pardon me. Quantity supplied went down by 750,000 sandwiches because the break-even price went up by $1, or the break-even cost, or the break-even point, because the price of chicken increased. That's what's driving the change here in quantity supplied. Okay, fair enough. I didn't ask you for that, so you don't have to put that. But if you want to notice things, you're not forbidden from noticing things. Okay. Well, now let's do our quantitative analysis down here in the table. We're looking at row 3. Okay, this is where we're looking. And let's see. Did quantity supply change? Yes. What is the new quantity supplied? 1.75 million. So the new quantity supplied is 1.75 million. You can indicate this, you don't have to, but I like to put the direction, so it actually went down, and the new quantity supplied is 1.75 million. Maybe it's not such a good idea to put that arrow because it looks like you're saying it went down by 1.75 million when that's actually the new quantity supplied. So in the test, I'll actually indicate that I want you to give me the new quantity supplied and not the change. If I ask for the change, I'll put the delta symbol, asking for the change. All right, quantity demanded. Well, did the quantity demand change? Oh, it's still right there at 2.5 million. So quantity demanded did not change. So we don't have a new quantity demanded. It's still the same. Okay, so you could either put a line or you could put 2.5 million. All right, because it stayed the same. Did the price change? No, the price did not change. So the prices did not change. Do we have a surplus or a shortage? Well, we have a quantity demanded of 2.5 million and a quantity supplied of 1.75 million. So people want more sandwiches than there are. Now, what do we call that? A surplus or a shortage? Pause the video and think about it. The answer is, drum roll, a shortage. We have a shortage. So we don't have a surplus. We have a shortage. Okay. Well, okay, so we don't have a surplus. What is the shortage? The shortage is given to us in this scenario. The shortage is 750,000 sandwiches. So you're going to put in here, the shortage is equal to 0.75 million or 750,000 sandwiches. And that's how you do that analysis. So you've completed analysis number 3. Check the box. Move on to scenario number 4. Ignore that point. My looks like my previous dot bled through the page. I'll just do some magic eraser there so you're not confused. And I will then relabel my graph. Okay, this is price, and this is quantity, and this is supply, and this is demand. We will label our equilibrium point, which is right here, and that is the equilibrium. My price equilibrium, I'm going to let that dry a little bit, so I'll draw on the quantity first. The quantity equilibrium is right here. That's Q sub E, and that's equal to 2.5 million sandwiches. And now my price equilibrium, right here, it's been the same for every problem so far, is $9, and that is the price equilibrium. Okay, so now we're ready to analyze scenario number 4. A food virus, oh boy, is discovered in Whataburger's lettuce, causing customer traffic to drop by 45%. So we have to decode some language. Customer traffic. What does that mean? What does that mean? Well, I'll give you 2 options. It's either a decrease in supply or it's a decrease in demand. Which one is it? Yeah, Jeopardy music. Customer traffic went down. Customers are the ones that are demanders, so that's actually a decrease in demand. Okay, so it has nothing to do with supply. Let's go back to a food virus is discovered in Whataburger's lettuce, causing customer traffic to drop by 45%. The way we interpret that, customer traffic goes down 45%, is we say that quantity demanded decreases by 45%. All right, so this is where your calculator will come in handy. How do you find out what a decrease of 45% is? Well, you say original value, so this is the original quantity demanded, is equal to the quantity equilibrium of 2.5 million. 2.5 million. And now you subtract out less, reduce 45% of 2.5 million. So what we're going to do is multiply 2.5 times 0.45, and we get 1.125. So we're going to subtract out 1.125 million sandwiches because that was the drop in customer traffic. It was given to us as a percent drop, but we just converted it into the number of sandwiches. And so now we just do this subtraction, 2.5 million sandwiches minus 1.125 million sandwiches equals a new quantity demanded of 1.375. So this is my new quantity demanded equal to 1.375. 1.375 million, or 1,375,000 sandwiches. Let's model it. Okay, I think you should be getting the hang of it at this point. We start with 2.5 million, and our new quantity demanded is 1.375 million. Well, I've only got this thing set up to increment by 0.25 million for each point, so we'll kind of find a point between 1.25 and 1.5. We'll just call it good right there. And this is the quantity demanded for scenario 4, right? This reflects the decrease in demand, in quantity demanded. So demand went that way, went to the left. And this is the new quantity demanded, 1.375. Okay. Well, now what do I do? What you do is take your ruler and you're going to dot out a vertical dot, dot, dot all the way through the graph until it, all the way through the graph. Okay. Now, what you're looking for is where that dot, dot, dot hits the price line. Well, it's already there. It's hitting it right there. Okay. So we know that we're going to draw a new curve through this point. But what curve are we going to draw? A demand curve or a supply curve? What changed? The foodborne pathogen, a virus, was discovered in Whataburger's lettuce, causing customer traffic to drop by 45%. So demand went down by 45%. Demand decreased by 1.125 million sandwiches. Demand decreased from 2.5 million sandwiches to 1.375 million sandwiches. So ladies and gentlemen, drum roll, round of applause. We're going to change the demand. We're going to shift the demand curve. All right, I'll try out purple on this one. And we're going to create a new demand curve that is parallel to the original, but just shifted to the left. And it's going to pass through, importantly, it's going to pass through this point. That's really the important thing. We'll take a look at something kind of cool here. So I've drawn that in, and we'll label it demand for scenario 4. Okay. Well, what we could stop here and just fill out our table, but let's look at something kind of cool. Originally, the y-intercept for the demand curve was $14. Okay, so at that point, the quantity demanded at $14 is 0. So that would be like the max price originally. That would be like the max price that people would pay originally. But now, because of the foodborne pathogen or the food virus, the max price went down. It went down to this point right here. So the new max price is $11.50. So I didn't ask you for this, but the max price decreased from $14 to $11.50 per sandwich. So that just reflects kind of how the consumer is reacting. They say, my goodness, your food is dirty, I don't want it, so I'm not willing to pay as much for it anymore. And that's just a little point on the graph that you can note. So you don't actually have to do that on your assignment, but if you want to do more than is exact thing that's asked of you, then you're free to do that. Okay, we are now ready, ladies and gentlemen, to look at our different variables for scenario 4. What is the new quantity supplied? I'm looking up here. I don't see the quantity supplied changed. So, because I wasn't clear about this, you could either draw a line through quantity supplied to say that there isn't really a new quantity supplied, or you could just put 2.5 million to indicate that it's the same as it was before, 2.5 million. What about the new quantity demanded? New quantity demanded. Well, we found that. That's the new quantity demanded is 1.375 million, and that was equal to 2.5 million minus 45% of 2.5 million, which we showed over here. And that gave us 1.375 million. So your new quantity demanded is 1.375 million. What's the new price on the menu? Okay, menu price. What's the new menu, or was there a change in price, I should say? Did we change this? No, there was no change in price. So there was no change in price. Does this represent a surplus or a shortage? Let's take a look. This is quantity supplied, 2.5 million. And this is quantity demanded, 1.375 million. So when quantity supplied exceeds quantity demanded, that is by definition a surplus situation. So we have a surplus, not a shortage. So that's a surplus, not a shortage. People want fewer sandwiches now. So Whataburger's got too many on their hands. And what is the total amount of the surplus? Okay, this is where your calculation is important. The change, okay, right there, that's the surplus value. So right there, this is the surplus. It's the difference between the original the quantity supplied and the quantity demanded. That's the surplus, 1.125 million. So go down here and put 1.125 million. And there was no shortage. So that's it for this graph. So put a checkbox by scenario number 4, and we'll move on to scenario number 5. You know, pause the video if you need to take a break, but I'm going to keep going. I'm on a roll. I'm enjoying this. This is fun. This is economics. What's not to love, ladies and gentlemen? Okay, so scenario 5, let me just quickly label my graph. You should be doing this as well. Supply, demand. And my equilibrium point here. This is the equilibrium point. And our equilibrium quantity, just like it was in the other graphs, 2.5 million. Put quantity equilibrium, 2.5 million. And price equilibrium is $9 per sandwich on the menu, ladies and gentlemen. So this is $9, and that's the price equilibrium. We're now ready to look at scenario number 5. Whataburger runs a sale on the honey barbecue chicken strip sandwich, dropping the price by $2 per sandwich. Aha! We have got finally an increase in the menu price. I'm sorry, I just said it wrong. A decrease in the menu price. We've got a change in the menu price, delta menu price. It says here they ran a sale on the honey barbecue chicken strip sandwich, dropping the price by $2 per sandwich. So the price goes down by $2 per sandwich. So we got to model that. Well, I'm excited because up until now, scenarios 1 through 4, we didn't change the price. But now we finally get to change the price. So I'm so excited. Yay, yay, yay. I can't wait to do this. I'm so excited that I'm going to use this. Let's use this green pencil to draw in our new value. So it went down by $2. So we got $9, $8.50, $8, $7.50, $7. So that's my new price point. So we'll label it $7. And this is the price for scenario number 5. Okay, so label it. Now I have the ultimate fun of drawing in this new price line. All right, so I'm going to make this dot, like, or hash, whatever, dot, all the way through the graph. I don't know if that's really visible, but we'll leave it like that. And here's the thing about this. So the thing is, when we just change the price and we don't actually shift the demand and the supply curves, we have a divergence. I'm going to use 2 lentils. to indicate this. So let me say we start out with these lentils, all right? They're both in the same point. I can't really overlay them, all right? But they're both kind of there in the same point. This is quantity supplied and quantity demanded. When I start this problem, they're both sitting right on top of one another. They're at the equilibrium point. For just a second they were there, but now they're not. All right, so here's what's going on. The guy runs, Whataburger runs this sale and they drop the price of their sandwich. So some person runs out and changes the menu price from $9 a sandwich to $7 a sandwich. So here's what's going on. We'll use the lentils. This will be very interesting to one particular person. We'll use the lentils. Now what's going on is as this price changes, the quantity supplied and demanded begin to diverge. So price changes, I should just point out, price changes move along the curve. Okay, they move along the curve. All right. So the quantity supplied, it will reflect by moving along the curve. So if the price is the only thing, the menu price changes, the quantity demanded and supplied change. So the quantity supplied will go down until that lentil is where the supply line and the new price meet. And now quantity demanded will go up. Okay. Why does this happen? Because, ladies and gentlemen, the law of demand says that when price goes up, quantity demanded goes down. And when price goes down, quantity demanded goes up. So is that what happened? Here, price went down. So the quantity demanded went up. It went up. All right. How about the supply law? It says when the price goes up, the quantity supplied goes up. When the price goes down, the quantity supplied goes down. So is that what happened? My lentil moved from 2.5 million, and as the price went down, that quantity supplied went down with it, and it came to rest right there. So what quantity do we have for quantity supplied? Well, so you're actually going to draw two ... dots. All right, so I'm going to move the lentil now and just mark in this point. Depending on how you drew this, you might have a slightly different number, but I'll put that point there. And then our other lentil goes away. Very sad. We may see them again, and that new quantity demanded is right there. Okay, so what is that? Well, we drop down a ... from the supply curve to find the quantity supplied. And that quantity supplied for scenario number 5 is equal to 1 million sandwiches. Okay, 1.00 million sandwiches. The quantity demanded went up according to the laws. Okay, these are the laws. The quantity demanded went up. It went up to 3.5 million. So I got quantity demanded over here went up to 3.5 million. Well, that makes sense, right? You run a sale on the sandwich, more people want the sandwich. It's like a coupon. More people want the sandwich because the price went down. Or you could say the same number of people want more sandwiches. Doesn't matter. Essentially it's the same thing. The quantity demanded went up. The quantity supplied went down in response to this change in the menu price. We're actually going to find out if this was a very good idea or not for Whataburger to do this. So now that we've kind of drawn in our points, let's go to our line item 5 and see what's going on. Do we have a new quantity supplied? Yes. Yes, we do. It's 1 million sandwiches. So we've got here 1 million sandwiches. Do we have a new quantity demanded? Yes, we do. So this one is 3.5 million sandwiches. And the other problems, we didn't change both of these at the same time, but when we change the menu price, we change both the quantity supplied and the quantity demanded. So it's kind of a more interesting problem. Did the price change? Yes, the price changed. The price went down. Okay, you can put a down arrow or a minus sign. Down by how much? What was the change in price? Okay, so don't write $7 here. You're going to give me the change in price. The change in price was $2. Okay, $2. We can even put a little dollar sign there so you know $2. Okay, you could have also said that, change in price was minus $2. However you want to write that, that's fine, but you need to show me that the change in price was minus $2. Okay, here we are again. Do we have a surplus or a shortage? Well, let's take a look. Our quantity demanded is 3.5 million. Our quantity supplied is 1 million. So do we have a surplus or a shortage? Well, quantity demanded exceeds quantity supplied. Quantity demanded is greater than quantity supplied. This means that we have a surplus. Okay? Quantity demanded is less than quantity supplied. I'm sorry, I said it just wrong. All right, let me take my white out because I'm doing this live, like Bill O'Reilly. I'm doing this live. I need to just erase that. So the quantity demanded exceeds the quantity supplied. We have a shortage. All right, it makes sense because there are more people demanding the sandwich than we have sandwiches. We only have 1 million sandwiches, but people are demanding 3.5 million, so we're short by 2.5 million sandwiches. So the quantity demanded exceeds the quantity supplied, is greater than the quantity supplied. That constitutes a shortage. If the quantity demanded is less than the quantity supplied, that would constitute a surplus. Okay, just got ahead of myself there. Sorry about that. This is live, so we make little mistakes, but we correct them. So that's called learning. All right. So do we have a situation where quantity demanded is less than quantity supplied, or quantity demanded is greater than quantity supplied? Well, quantity demanded is 3.5 million. Quantity supplied is 1 million. So we have quantity demanded greater than quantity supplied. Therefore, that is this one. Therefore, we have a shortage. Okay. I'll show you something cool in a second, but first let's do this. So we don't have a surplus. All right, I made that abundantly clear by making a mistake. Now, we have a shortage, so we do not have a surplus. We have a shortage. What is our shortage equal to? Well, it's equal to the difference between the quantity demanded and the quantity supplied, 3.5 million. So the surplus, or shortage, I'm going to get it right eventually. The shortage is equal to 3.5 minus 1.00. Right? So the shortage is equal to 2.5 million sandwiches. So that's actually what you're going to write down here. You're going to put the shortage is equal to 2.5 million sandwiches. All right. So we found a shortage. This is kind of cool. And when you see a shortage like this, you can actually highlight the triangle formed right here to indicate the shortage, if you want to visualize it. That's the shortage. Right? It's this area here of this strange looking triangle. Yeah. That's the shortage visually. So that is the shortage. You're going to put a little arrow. This is the shortage. Okay? So I didn't ask you to do that, but you can. So there is scenario number 5. Let's put a check mark there and move on to scenario number 6. Now in class, I ask you to do scenario 6 and 7 on your own, but we will do them together. Okay, so we're on to scenario 6, the final 2. Let's relabel our curve. Price, quantity, supply, and demand. I've got my equilibrium point right here, and I've got my equilibrium quantity right here, that's Q sub E, and that's 2.5 million. And I've got my equilibrium price right here. That's $9, okay? And that's equal to, that's the price equilibrium, okay? Well, now we're ready to look at scenario number 6. Let's take a look at scenario number 6. All right, scenario number 6. Scenario number 6 says, if I read it, Whataburger increases the price of all of its menu items by 15% due to rising employment costs. All right, this is a pretty real world situation. So people cost money. You have to pay your employees. So the employees cost money, and we're saying that the cost of the employees, or what they demand for their hourly wage, maybe they went on strike or something, and so you have to pay them more, all right? So because you have to pay them more, you're going to pass that cost along to the consumer. So you're going to make people pay more at the drive-through window because the employees cost more. If you remember, there was a story a while back when Barack Obama passed the Affordable Care Act. Sometimes it's called Obamacare. Papa John's opposed this. The owner of Papa John's, I think his name is John Shatner, he opposed this, and he said he was going to add an Obama tax or an Obamacare tax to all the pizzas, and he was also going to cut his labor. Anyway, my point is employment costs go up because Obamacare was going to cost him more money to insure his employees. He was going to pass that cost along to the consumers. It's kind of a way of protesting that that he had to pay more insurance cost. Okay, so we're going to model this. It says here, Whataburger increases the price of all of its menu items by 15% due to rising employment costs. Well, the honey barbecue chicken strip sandwich, okay, is a menu item, and that menu item's price is $9. So we're increasing that by 15%. That's what we're doing. So we can say $9 plus 15% of $9. All right, will give us our new price, our price for 6. So let's find out what 15% of $9 is. That's 0.15 times 9. 1.35? Okay, so let's see, equals $9 plus $1.35 will equal our new menu price for the honey barbecue chicken strip sandwich. So the new price is $10.35. $10.35. Okay, this is equal to the new price, or the price of scenario 6. Okay, so let's model that on our graph. We got another one, guys. Clap, 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 golf clap. We got another price change. So this is exciting because there's a lot that goes on when the price changes on the menu. What color are we going to use? I think we will use, I used green for the last one, so I shall use blue for this one. Okay, very excited to use blue. All right, so the price goes up by $1.35. Well, we don't have it marked out. We've got it marked out in 50-cent increments. So I'm going to go up $1 to 10, and then I'm going to try to go somewhere between 10 and 10.50 to indicate $10.35. So your individual results may vary, but I'll just put the point right there, and I'll call this 10.35. And this is the price for scenario 6. Well, I'm very excited to extend out this price line to cross through both the demand and the supply curve. So that's kind of the work that you do here. And in this case, we get our lentils back into the picture. and they're both going to have started at quantity equilibrium, but now the price went up. So since the price went up, our quantity demanded goes down. Remember that according to the law of demand, when the price goes up, the quantity demanded goes down. And according to the law of supply, when the price goes up, the quantity supplied goes up. Okay, so let's make sure that the laws work. Well, we'll start with the demand. The price went up. Okay, the price went up, ladies and gentlemen. So the quantity demanded goes down. Well, let's just move our lentil along the demand curve until it's resting at the intersection of the price and the demand curve. All right, so we'll put it right there. How about supply? Price goes up, quantity supplied goes up. So our supply is going to go up, right? So demand decreased and supply is going to increase until it's right there. Okay, whoop, there we go. So again, our quantity supplied and quantity demanded diverged. So we have to model that. Well, the divergence can be modeled. If you drop down those quantity markers, the lentils, you'll have quantity demanded lower than the equilibrium, and that's equal to 2 million. And quantity supplied, again, let's see exactly, the thing hits it about right there. Okay, so the quantity supplied, if I drop down that vertical dot, quantity supplied increased to 3.25 million. So quantity supplied is at 3.25 million, and quantity demanded is at 2 million. All right, so we'll get rid of our lentils, for now, and we will go to our table. Item number 6. So do we have a new quantity supplied? Yes, we do. The quantity supplied went up because the price went up to 3.25 million. So on line 6, we put 3.25 million. Do we have a new quantity demanded? Yes. The price went up, so quantity demanded went down, and it went down to 2 million. So here we'll put 2 million sandwiches. Did the price change? Yes. Right? The price went up by 15%. So what does that equal? What is the price change equal to? Well, it's equal right here. So if you took a shortcut to find this, then right now you're scrambling because the long way around gives you, this is the change in price. Okay, it's $1.35. So you'll go over here and say that the price went up by $1.35. Okay, indicate that. Do we have a shortage or a surplus? So I'll try this again. I screwed it up in the last example. But if quantity demanded is greater than quantity supplied, we have a shortage. Okay, that's a shortage because people want more than we have. If the quantity demanded is less than the quantity supplied, we have a surplus. Okay, because people want less, we have too much in our inventory. So what have we got here? Quantity supplied is 3.25 million. Quantity demanded is 2 million. So it looks to me like quantity supplied is greater than quantity demanded, and that means we have a surplus situation going on. Okay, so we have a surplus, not a shortage. So this is not a shortage. And what is the amount of the surplus? Well, we actually have to calculate that. The quantity supplied is 3.25 million. That's the quantity supplied. And subtract out the quantity demanded of 2 million. All right. And you find your surplus value is equal to the subtraction there, and that is 1.25 million. And this is the surplus. So the surplus is equal to 1.25 million sandwiches. Okay, so was it when employee costs go up, it hurts the company because the quantity demanded dropped and the quantity supplied increased, and it created an imbalance in the market. And once again, just like with shortage, you can highlight the surplus, and that would be indicated by this area right here. That little triangle, that's the surplus. When we start talking about government price controls, these shortages and surplus triangles will become important. But for now, we'll just point out that that is the surplus. Okay? So looking at number 6, we're done. So put a check mark, and we'll go to our final example. All right, we've arrived. Let's see. First, we'll label our graph before we do the analysis. Price, quantity, supply, demand. Then I'll indicate the equilibrium point right here. And I will draw the quantity equilibrium at 2.5 million. That's the quantity equilibrium, 2.5 million sandwiches. And the price equilibrium is equal to $9. Okay, so $9 is the price equilibrium. Fair enough? Okay. Let's see what is going on in scenario number 7. It says here, drive-through traffic accounts for 60% of all sales. Okay, interesting. The drive-through lanes are shut down for maintenance. All right, plausible. Drive-through customers choose other fast food restaurants instead of coming inside. Well, that is a lot of words. What is being said here? Well, the only number we're given is 60%. It says here that drive-through traffic accounts for 60% of sales. Drive-through lanes are shut down. Okay? Those customers that account for 60% of all sales go somewhere else. You know, they don't go to Whataburger. Because if you're in the drive-through lane, you're there for a reason. You don't want to go inside the restaurant. So if the drive-through lane is closed, we're assuming that 100% of the people that would have purchased sandwiches at Whataburger are going to leave and go to McDonald's or Taco Bell or Arby's or KFC or Chicken Express or some other restaurant. Okay, Burger King, Jack in the Box. They're going to go somewhere else. Okay, so what we're saying here is that we have a drop in demand. We're going to say that demand will decrease by 60%. That's what's going on in this example. If you can see that, then you're kind of on your way. That was the trick with this example, is to recognize that drive-through traffic meant demand. Okay. All right. So let's figure out what that means. We're going to be decreasing the quantity demanded by 60%. Well, the original quantity demanded. This is the quantity demanded original. Okay, this is the original. Was equal to 2.5 million. Well, now we're going to say that that quantity demanded decreases by 60% of 2.5 million, since 60% of all traffic is accounted for by drive-through customers. So let's find out what 60% of 2.5 million is. Using our calculator, we'll take 2.5 times 0.6, and that's 1.5 million. So I'm going to subtract out 1.5 million sandwiches to indicate the 60% drop in demand since the drive-through lanes are closed. So my quantity demanded for scenario 7 is equal to 2.5 million minus 1.5 million, or 1 million. 1 million sandwiches. Okay, 2.5 minus 1.5 equals 1 million sandwiches. So that's my new quantity demanded. Oops, I forgot to put quantity demanded for scenario 7. Right? I should have written quantity demanded 7. Right? I don't know if I've been consistent with that, but that's what you should be doing. All right, so now we're going to go down to 1 million on our quantity right there. And we will draw in our new point. So this is our quantity demanded 7, and we'll draw in our new quantity demanded and see where it passes that price line. Okay, so there we go. The place where they meet is right there. Okay, so that's where they meet, where the price and quantity meet. Now, does this indicate a shift in supply or demand? Well, the drive-through lanes are closed, so we're not changing supply, we're changing demand. The customers don't come inside the restaurant, so they go somewhere else. So they decrease their demand for the product because they couldn't come inside the restaurant. So they just lost that drive-through traffic. So we'll indicate, we'll point there. And we're going to draw in a new demand curve. Now this time I'll use orange and make your lines parallel. And we're going to have it pass through this point right here. So we're shifting demand down. Okay, so this is my new demand for scenario 7. All right, that's what that is. Okay, so we can do our analysis now, and we'll be finished with the activity. Drive-through traffic accounts for 60% of all sales. Drive-through lanes are shut down. Customers go elsewhere. Did we change quantity supplied? No. So there's no new quantity supplied. We can just put a mark through that, or we can indicate that quantity supplied is still 2.5 million. Whatever you want. Quantity demanded. There was a change. So we've got a new quantity demanded, and I should have written it in. That is equal to 1 million. 1 million, right? So we'll go over here and indicate that we do have a new quantity demanded, and that new quantity demanded is 1 million. Question: did price change? No, price did not change. So go down here and mark through. We don't have a change in price. Okay, now we're back to our surplus shortage situation. Do we have a surplus or a shortage? Well, for one last time, if quantity demanded is greater than quantity supplied, that's a surplus. I'm sorry, that's a shortage. If quantity demanded is less than quantity supplied, that's a surplus. Okay, so what do we have here? Do we have a surplus or a shortage? Quantity supplied stayed the same at 2.5 million. Quantity demanded dropped down to 1 million. So we have a situation where quantity supplied is greater than quantity demanded, therefore we have a surplus. So this is a surplus situation and not a shortage. Okay, so there's no shortage. Well, what is the value of the surplus? That is just equal to the quantity supplied equals 2.5 million, okay, and the quantity demanded equals 1 million. So the value of the surplus is 2.5 minus 1. 2.5 minus 1. 1.5 million. All right. Notice that 1.5 million is equal to the drop in customer traffic, so we'll bring that value down here and say 1.5 million is the surplus. All right, so that's the value we put here. The surplus is 1.5 million. Okay, that is it. You have completed that example. So that's example 7. Here's example 6. Scenario 5. Scenario 4. Scenario 3. Scenario 2. And scenario 1. If you did all this work, I'm quite proud of you. Good job. You should at this point have kind of a feel for how these different scenario descriptions will result in changes in either the price or either the quantity supplied or quantity demanded. And then you'll vary those points around and draw either a new supply curve, a new demand curve, or a new price line, and determine your values by reading points off of this model. And this really should give you a demonstration of just how powerful supply and demand analysis can be. I hope also that this has proven useful in the sense that we used a real world product, the honey barbecue chicken strip sandwich, at a real world company, Whataburger. And we analyzed using a real world price of $9. And we saw how these market changes could really affect a real life restaurant. So if you work in food service, or a number of my students do, I certainly have worked in food service before, then this is all directly relevant to you. You know, if you learn how to do this and you get a college degree or an associate's and you go to a food service establishment with this, this is what managers do. Okay, this is what business owners do. So you'll make more money. Doing this homework will help you make money. I hope that's an incentive. Thank you so much for watching and paying attention. Please make sure to like and subscribe. Thank you.